Hi, my name is Steve Kenniston, Vice President of Technology Strategy for Storwize, and welcome to today's Compressed Thought. In our past few videos, we've talked about real-time compression for Storwize as a part of our secret sauce. One of the other components of our secret sauce is what we call random access compression. What do we mean by random access compression? We know what random access storage is, but what's random access compression? The nice thing about random access compression is it really aligns with random access storage because that's how data is actually written in the real world. So let's take an example. Let's take a 384 kilobyte PowerPoint presentation, and you'll understand the number here in a second. And let's assume we're in an NFS environment, and let's assume we're getting a 4:1 compression ratio on this particular PowerPoint file. So with NFS, it writes in 32K chunks, right? So we're going to break up this PowerPoint file, and we're going to send that PowerPoint file through the Storwize appliance. Storwize is then going to start compressing the file and storing that file, and because we're getting a 4:1 compression ratio, we're going to store 4 96 kilobyte chunks of information. And inside those chunks of information, the data will be compacted and reduced. So the first thing that Storwize is going to do as the data is written through the appliance is we're going to write out the file envelope. And by preserving the envelope of the file, what we're doing is we're ensuring that the file is transparent to the application that's writing it. In other words, as this compressed file lives on disk, I can read it, I understand it, the file permissions are the same, the owner is the same, the file size looks like the original file size to the application. This ensures the transparency to the application. For more on that, take a look at the video that talks about Storwize and transparency. Once the file envelope is written out, we then start taking the compressed data and putting it inside the file envelope. As this file begins compressing, components of that file are then written into the file envelope. The nice thing about having the data inside the file envelope in these logical units is that when a user needs to edit a piece of that content, Storwize does not need to decompress the entire file. We just need to decompress the logical unit of the file in order to then do the modification on the file. Why is this helpful? It's helpful for a number of reasons. One, we preserve the compression ratio of this file. So without adding fragmentation, Storwize is able to decompress the file, decompress the component of the file, make the modification, and write it right back in to that segment of the file. Number two, it allows us to ensure no performance degradation. By only reading and writing smaller pieces of the compressed file, we're doing less I/O, that's less overhead on the array, and we're ensuring storage performance. And the third thing has to do with your downstream processes. Most companies that do backup, especially in the data deduplication arena, will tell you to decompress your file before you actually do the backup. The reason for that is that compression, normally, traditional compression, messes up deduplication ratios. With Storwize, because you're doing modifications to small components of the file, you're actually preserving the deduplication ratio of the file. So the benefits are maintaining your deduplication ratio, ensuring that there are no downstream performance effects, preserving the performance of your storage array, and aligning to your downstream processes such as backup and data deduplication. Thank you. My name is Steve Kenniston, and that's today's Compressed Thought.